Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3. They're coming rapid fire today. And just going to share with you a little bit more about some of the programming that I do and some of the stuff that I learned in my later years at WRAL and still use today. And I'm not an expert programmer, so it takes me longer to figure out how to do things than a professional does. In fact, if you are a programmer, you'll probably be laughing quite hard when I show you some of this stuff, but it's best I can do. All right, so let's go on ahead and take a look. There's a neat thing, in fact, let me get off to the side here. A neat thing that NOAA has where they have a site called nomads, nomads.ncep, ncep.noaa, noaa.gov. And basically, instead of having to download all of the data from a global model for the entire world, you can pick out the 1 or 2 parameters you want to look at the levels you want to look at, and the area that you want to look at. And so when you take a look at this URL here, if you go down to the second line over toward the right, you see the year 2025, the month 01, January, the date 31 today, and then the 12 means it's the 12Z run. Greenwich time is Zulu time, and it's 5 hours ahead of us. So 12 Zulu time is 7 a.m. Eastern Standard Time, okay? And then you go back here, and the name of the model is the GFS. That's the American Deterministic Model. Again, it's 12Z, the runtime. And this means that the resolution is a 1/4 of a degree, so it's fairly high resolution. And then the forecast hour for this particular URL is 6. And they always have 3 characters because the forecast hours go out to 384, so they just want to have 3 characters all the time, and I'll talk more about that in just a little bit. Then the variable, PRMSL, means sea level pressure, okay? Then we go back here, Tmax is the maximum temperature for whatever time period you're looking at, Tmin is the minimum temperature, and then you set the level. And the temperature that we all observe is 2 meters above the ground, so 2m above ground. And then the isobars, the sea level pressure, is at mean sea level, appropriately enough, and so level, mean, sea level. Then you see subregion, and the top latitude is 37 degrees north, the left longitude is -80, the right longitude is -77, and the bottom latitude is 34. RDU is about 35.9 north and 78.8 west. So instead of downloading data for the entire country or the entire world, I can just say, hey, let's make a little box right around the triangle and just download the data for that particular area. So it really, really makes it nice. The only problem is that this site only has archived data back about 4 or 5 days at most. And so in order to go back farther than that, I've got another method that I have to use, but unfortunately it doesn't have quite as much variability or as many options as this does in terms of limiting the area that you're actually downloading data for. Okay, so here's a little bit about some basic programming. So you have to basically define variables. Supposing you wanted to go through a loop, or you want to take a look at the 6-hour forecast, and then the 12, and then the 18, and then the 24. So you can set up a loop that will do that. And so you define variables, and this is the same URL you saw before. It's just that now I've set up a variable YYYY, which stands for the year, MM for the month, DD for the day, HH for the forecast, or for the runtime, okay, the hour. And then you'll notice that over everything else is the same, and then where is it here? Oh yes, right over here where it has F $ bracket FF close bracket, okay? FF is my forecast hour, okay? And remember I told you that it had to be 3 characters, and so how do I tell the computer to do that? Well, if FF is going to start off at 6, okay, then I have to ask it a question. Well, first, before I do that, I've got to tell it how far out do I want to go. I want to go out 120 hours, okay? So I'm going to start at 6, and I'm actually going to go at intervals of 6. So 6, 12, 18, 24, all the way out to 120 hours, okay? Now, I have to give it this question. If the forecast hour is less than 99, then you're going to have to put a 0 in front of it because we need to have those 3 characters, okay? So now FF is equal to 06, 06, okay? But we still don't have 3 characters, so we have to ask it another question. Is it less than 9? And if it is, put another 0 in there, okay? So now F is equal to 006, which means in the URL, the computer will be happy and say, ah, I know what he means now, and go on ahead and download that data, okay? Now, you have to get it back to a single character because if you don't, when you go through the loop the next time, it's going to keep adding zeros and you're going to have F00000006 and the computer's not going to know what the heck to do with that. So how do you do that? Well, at the end of one cycle, you do this. You have F equals, and don't ask me who came up with the nomenclature here, but this is just the way you do it. The 10 pound in front of the $FF takes away those zeros, okay? So now you're back to FF equals 6, and it's telling it to add 6 to that. So now FF is 6 plus 6 equals 12. When I go through the cycle the next time, 12 will be less than 99, so I'll have to put a 0 in front of it, but it's no longer less than 9. So I'm only going to add 1 0 the next time as opposed to the 2 that I have to do it when it's 6, okay? And then you have a done down there at the bottom, which means that you are finished with your loop. You've gone all the way through your 120 hours. Okay, so if you want to look at data more than 4 or 5 days back, there's a gentleman up at NOAA who's going to retire soon. His first name is Wesley, and I cannot remember, I can't pronounce his last name, okay? But this guy has been a godsend to me. When I first started communicating with him back, again, in my later years at WRAL, he would respond to my emails almost immediately, and he has no idea. I mean, he literally changed my life because from what he taught me, we could download any data set we wanted from NOAA and we could manipulate that and get it into our graphics system. And we were showing stuff that nobody else in the country could show because their vendor didn't supply it to them. So unless they were willing to go to the trouble to write programs, they weren't able to show the stuff that we were showing. And that was exciting because that meant every morning when I got up, if I had an idea, there's a good chance I could get that on the air that night. So that was pretty cool. But anyways, Wesley wrote 2 programs, and I think you have to have Perl on your computer to be able to run these. But the first one is called get_inv.pl, and that PL refers to Perl. So there's what's called an index file for every model file that there is, and it basically tells you everything that is in the file, okay? And so I've still got my variables, the y, and mm, and all that sort of stuff. But notice at the end here, it has IDX, and that stands for index file, okay? And now I'm going to have 2 variables because the way the file is set up, a forecast at 12 hours for precipitation is actually a 6 to 12 hour forecast. And so I have an FF start, which is the 6, and an FF end, which is the 12, okay, or whatever the range is. So that's the index file. Then the other program is getGrib. All the model data is in GRIB format, which stands for gridded binary. And so getGrib.pl actually looks at the actual data file and looks at the index file to see what's in it, and it combines those two to download a file, okay? And I'm calling that file 1.grib2. That's what I'm calling the file that I'm downloading, and I'll explain why I'm doing that in just a second. In the middle, you have a program or a command called grep, which is basically a search command, okay? So I can either do a search for this, which is going to be in the index file, okay? APCP, which stands for precipitation, at the surface, and we're going to go from FF start to FFN, so maybe 0 to 6, 6 to 12, whatever, okay? And then it says hour accumulated forecast, okay? Now, I can either do that, or I lucked out today and found out that you can use a record number. So if there are 150 variables in this file, and you know for a fact that the variable you're interested in is always the 69th, then you can do this. You can do grep and then a little up arrow sign there, and 69, which means it will automatically go to the 69th line in the file, and you won't have to worry about all this stuff over here, okay? So that was a nice thing to discover today. That saved some time. Okay, now I mentioned that I saved the file as 1.grib2. Why did I do that? Because every time I download a forecast hour, I want to keep adding on to that and get it all into one file instead of having a gazillion separate files, okay? So one of the programs, other programs that Wesley wrote was this program called wgrib2. It's like a Swiss Army knife for grib data. And so what I'm saying here is take 1.grib2 and append it, okay, to a file that I'm going to call this, which is GEFS, and then the year, the month, the day, and the hour.grib2. And then once it combines that or appends that file with 1.grib2, then I say, get rid of 1.grib2. I don't need that anymore. And the next time I go through the cycle, then it will create another 1.grib2 and append that to the main file and delete it again, and so on and so forth. Okay, so that's the method of the madness behind that. And then finally, I just thought you might find it interesting to see how I decide how I'm going to construct my loops. Supposing that I wanted to compare forecasts from the current run to the previous run to the previous run, but all verifying at the same time. So I make up a table of all my variables, what I want them to be at certain times, and then I say, okay, how do I make that happen? Okay, so in this case, I start off at the top with the year 2025, January 18th, and the run is from 0Z, 0 hour Zulu, okay? And I'm going to go from 0 to 24 hours. So I want to see maybe how much precipitation is going to fall in that 24-hour period, okay? Now I want to go to the previous run, okay, which is 6 hours earlier. So now this is 2025, January, but now it's the 17th at 18Z, okay? It goes every 6 hours. So if you go backwards from 0, you're the previous day at 18Z. But in order for this to verify at the same time this is going on, I've got to increase the forecast range from 6 to 30. Then I go back and I'm still on the 17th, but now I'm at 12Z. Okay, that's 6 hours earlier, which means I've now got to go from 12 to 36. And then here I'm down to 6Z, and I've got to go 18 to 42, and so forth, until you get all the way back here on the 16th at 0Z, and your forecast hours are 48 to 72, okay? So if you make a table like this, and then sometimes what I'll do is I'll have a variable called counter, okay? It's just literally a counter. And I'll say, hey, if that counter gets to this number, then change this variable or go back to this value, okay? And so that will tell the program to do what I want it to do to achieve these numbers that you see here in this table. So that's one of the ways I help myself to decide exactly how I want to write the program. Okay, that's it for now. I hope you found that interesting. It's sort of fun. The only thing I will say is that I'll run the program and I'll get an error, and it'll say, you screwed up on this line here. And I'll look at it and I'll say, I didn't screw up, it's perfectly okay. And then I look at it more carefully and I realize that I've got a semicolon instead of a colon, or a period in the wrong place. It's very unforgiving. It has to be perfect or it ain't gonna work, okay? And so it takes me a little longer than it does somebody who does this professionally, because I make those stupid little mistakes that drive me crazy. But in the end, finally, when you get it working, it is very, very satisfying. Okay, that's it for now, folks. You all have a wonderful Friday evening, an even better weekend. Happy February, and we'll talk to you again on Monday. Take care.